Good morning, students. Dear students, before discussing today's topic, that is part 8 of motion in a straight line, first of all, I want to say that stay at home, keep doing studies. As you are seeing that COVID cases are increasing, so stay at home and keep doing studies, enhance your knowledge, and you are the future of the nation. So keep it in mind. And now we are going to start today's discussion. As in the previous video we had discussed about average speed. We had discussed about average speed, and in case of average speed we had discussed average speed of an object is the total distance traveled by the object divided by total time taken to cover that distance. Total distance divided by the total time taken, and so average speed is total distance traveled. Average speed, V average, is equal to total distance traveled upon total distance traveled upon total time taken. Now we are considering here two cases to find out the average speed for the given object. So we are discussing that two cases. Case first, if a particle is covering a distance, covers a distance s1, s2, s3 up to these are the different distances. S1, S2, S3 and Sn are the different distances in an interval of time with speed. Time is not given here. With speed v1, v2, v3 up to shown vn. Means there is a particle, there is an object, and that object is traveling s1 distance with velocity v1, s2 distance with velocity v2, s3 distance with velocity v3, and sn distance, nth distance with velocity vn. In that case, the average velocity, average speed, you can say that average speed can be calculated as total distance traveled upon total time, total distance traveled upon total time taken. Now, what is the average speed, total distance traveled? What is the total distance? Total distance V average can be given as total distance, that is S1 plus S2 plus S3 plus up to shown Sn. And as you know that total time taken, but in the question there is no specification about time is not given in this question, so we have to calculate the time, and the time can be calculated as distance upon speed, because speed is equal to distance upon time. So distance upon speed, S1 V1, S2 V2, S3 V3 plus up to shown Sn Vn. This is the time. And where T1, you can say that T1 is equal to S1 V1, T2 is equal to S2 V2 up to so. T1 is equal to S1 upon V1, T2 is equal to S1 upon S2 upon V2, T3 is equal to S3 upon V3, and Tn is equal to Sn upon Vn. Now, if we put the speeds S1, S2 up to shown Sn is equal to S. If S1 is equal to S2 is equal to S3 equal to up to shown Sn, that is equal to S. All the distances covered, we had supposed all the distances covered as S. Then in this case, V average can be calculated as S plus S plus S plus up to shown S, n times S, that is n times. And similarly, S upon V1 plus S upon V2 plus S upon V3 plus up to shown S upon Vn. Now, taking S common, it will become n into S, and S common out, taking S common out, 1 upon V1 plus 1 upon V2 plus 1 upon V3 plus up to shown 1 upon V1. S to S cancel out, and it will be V average is equal to n 1 upon V1 plus 1 upon V2 plus up to shown 1 upon Vn. Now, what we are doing, we are going to simplify it for three distances. Here I had taken a general expression. This is the general expression. This is the general expression for average velocity when the object is moving with the same moving same distances with different velocities. S distance with velocity v1, S distance with velocity v2, S distance with velocity v3, and in that case we had derived the general result. We had derived the general formula. Now we are doing what? We are restricting it for three distances. Then what will be the value of V average? V is equal to S plus S plus S upon s upon v1 plus s upon v2 plus s upon v3, and here we get 3s and s 1 upon v1 plus 1 upon v2 plus 1 upon v3. S to s cancel out and it will become v1 into v2 into v3. v1 to v1 cancel out, it will become v2 into v3 plus v1 into v3 plus v1 into v2, and it will become 3 v1 v2 v3 upon v1 v2 plus v2 v3 plus v1 v3. And what is this? This is nothing. This is the harmonic mean of individual speeds. This is the harmonic mean of individual speeds. This is the harmonic mean of individual. The same thing is that for n we had calculated and we had summarized it for 3 cases, and after summarizing it for 3 cases we had seen it is nothing, it is simply the harmonic mean of individual speeds. You had studied about harmonic progression in mathematics, and in that case you had studied about harmonic mean. So when the object is moving with different velocities, but with different velocities it is covering equal distances, in that case the average velocity can be calculated as simply be calculated as harmonic mean of the individual speeds. Now this is the case first. Now we will discuss about case second. If the particle is moving with the velocity v1, v2, v3 up to so v1, vn in time t1, t2, t3 up to so tn. Now look at here. If a particle moves with a speed, case second, if the particle moves with the speed v1, v2, v3 up to soon vn in time t1, t2, t3 up to soon tn. If the particle moves with velocity v1, v2, v3 with the time interval, that the time is given t1, t2, t3. So average speed in this case, average speed v average in this case can be calculated as total distance traveled. So since distance is not mentioned here, distance is you are given only with the speed and time. You are given only with velocity or speed and time, and in this case distance is not given, but in average speed there is the formula total distance traveled upon total distance traveled upon total time taken, and the total distance traveled is what? That is total distance traveled is equal to a speed into time. That is speed into time. and it is equal to V1 T1 plus V2 T2 plus V3 T3 plus up to so on upon time T1 plus T2 plus T3 plus up to so on, time T1 plus T2 plus T3 up to so on. Now let us suppose that here I am taking a specification. If it will happen that whatever the time you had considered, what for speed v1, the object or the particle is traveling with the speed v1 for time t1, v2 for time t2, v3 for time t3, and vn for time tn. So if a specialization or a specification I will do that, okay, for traveling with the speed v1 the time taken is t, for traveling with velocity v1 v2 time taken is t, for traveling with velocity v3 time taken will be t. Means this time interval becomes same. Means we can say that t1 is equal to t2 is equal to t3 is equal to up to so on Tn, that is equal to T. In that case what will happen? In that case V average can be given as V1 into T plus V2 into T plus V3 into T plus up to so on Vn into T upon T plus T plus T plus up to so on n times, and it will happen what? It will happen taking T common, T is equal to V1 plus V2 plus V3 plus up to so on Vn upon n times T, T to T cancel out, and it will become what? It will become V1 plus V2 plus V3 plus up to so on Vn divided by n. Means in this case, if an object or a particle is traveling with different velocities in equal interval of time or equal interval, suppose I am saying that okay, and a particle is traveling 3 meter per second for first second, 4 meter per second for second, matlab in 1 second, 5 meter per second in 1 second, 6 meter per second in 1 second, means t is same but the velocities are varying. So average velocity or average speed can be calculated as the sum of all the velocities divided by the number of velocities, and by taking the average of the number of velocity you can calculate. In this case, only in this case, if the times are different then you have to add like this, but if the time are same, in the question time all the time given are same for different velocities, then in that case we generally use to opt for the average velocity, that is v1 plus v2 plus v3 divided by the number of velocity. That is, you can write like this: V average is equal to average of all the velocities, that is, if 3 velocities are given v1, v2 and v3, then in that case you can calculate v1 plus v2 plus v3 divided by 3. Now there are certain differences between average velocity and average speed. Average velocity is the net displacement, you had studied, it is the net displacement divided by the time taken, net displacement divided by the time taken for that displacement, net displacement upon the time taken for that displacement, total distance divided by the time taken, that is the average speed. Average speed net total distance traveled upon time taken is the average speed. And one thing is that, one thing I want to add here, one thing I want to add here, that is average velocity can be positive, negative or zero, but average speed is always positive for a moving body, always positive for a moving body. Yes students, now we will go for a numerical based on average speed and average velocity, and look at the question. A car is moving along a straight line is given here. A car is moving along a straight line, and say OP, it has, suppose the OP is the straight path. It means that it moves from O to P in 18 seconds. From here to here it is moving in 18 seconds, and returns from P to Q, in 6 seconds. What is the average velocity? And a very simple question, what is the average velocity and average speed of the car in going from O to P, and from O to P and then back to Q? Very simple. Average speed, case first we are taking, and first of all we are discussing about average velocity. In first case, average velocity, and this average velocity is the total distance traveled. Average velocity is the net displacement upon time taken. So it is the question had asked from O to P. So O to P in 18 seconds it is given, and it is already given in meter. So from O to P, average velocity is equal to net displacement upon time taken. Net displacement upon time taken. So what is the displacement? This is 360 from O to P. 360 is the final position, and origin is the initial position. Origin is the initial position, and 360 is the final position. So net displacement is final position minus initial position, that is 360, and time taken, time is given, this is meter, and time it is given 18 seconds, and it will be the 20 meter per second. It is the value of the average velocity. Now average speed we have to find out. So average speed, since it is moving in a straight line, then in this case whatever the displacement, the same will be the distance traveled for the body moving in the straight line. So total distance traveled upon total time taken, and total distance traveled is what? Total distance traveled is 360 meter upon total time taken is what? Total time taken is 18 seconds, and it will also be 20 meter per second. So this is the case for the average speed. Means in this case, when the body is moving in a straight line, the average velocity is equal to the average speed. Now we are talking about the second case, that is body is moving from O to P and then back to Q. O to P and then back to Q. So since the object is moving from O to P and then back to Q, means the final position is 240 and the initial position is origin. So net displacement, V average net displacement upon time taken, and it is equal to net displacement is equal to 240 upon, it moves from O to P in 18 seconds and return from P to Q in 6 seconds. So total time is what? 18 or plus 6. I think 18 plus 6. 18 plus 6 second, and 18 plus 6 is equal to 24. So plus 240 meter upon 24 second, and it is equal to plus 10 meter per second. The velocity will be plus 10 meter per second. Now in the second case we will discuss about the net path length, since it is asking about, the question is asking about average speed. Average speed in the second case, average speed. So average speed, it is equal to total path length upon total time, total path length upon total time taken, and total path length is what? 360 plus 360 minus 250, that is 100. 360 minus 240, that is 120. So it is equal to 360 meter plus 120 meter, and the total time taken is 18 second plus 6 second, and it will be equal to what? It will be equal to 360 480 meter 24 second. Clear? 480 meter 24 second. 24 2 20, that is 20 meter per second. So average speed will be equal to average speed and average velocity we had calculated. Average speed and average velocity we had calculated. Yes, now this is the second question. It is a quite moderate question. Look at here. A car covers the first half of the distance between two places. There are two places A and C, and this distance AAC is divided into two equal halves. So the distance between two places, first half of the distance between two places with the speed of 40 km. First half it covers with 40 km per hour, and second half at 60 km per hour. This first half with 40 km per hour and this second half with 60 km per hour. Calculate the average speed of the car. Calculate the average speed of the car. So look at here. The speed of the car, that is V1 for the first half, it is given as 40 km per hour. V2, that is the speed of second half, that is 60 kilometer per hour. These two distances, and we had supposed that the total distance between two places, total distance between two places is equal to x. Total distance is x. Then it is obviously that first half is x by 2 and second half is x by 2. So time taken for the first half, let t1 time taken for first half, is t1, and t2 is equal to time taken for second half. Time taken for second half is t2. Now what we have to do, we have to calculate these times, that is t1 and t2. So first half t1, and how can you calculate the time? You have to calculate the time total distance upon distance upon velocity. So for first half, it is covering the distance x by 2, so x by 2 is the distance, and for first half the car is traveling with the velocity v1, that is 40, and t2 is equal to x by 2 upon 60. Time t1 is equal to 40 and time t2 is equal to 60, and you can calculate, write it as x upon 80 hours and x upon 120 hours. This is the time, and distance is known to you. Total distance is x by 2 plus x by 2, x by 2 plus x by 2. So for calculating the average, what you have to calculate? You have to calculate the average speed. Average speed, that is v average, and it is equal to total distance traveled, that is x by 2 first half, x by 2 second half, total distance traveled upon total time taken. The total time taken, t1 is equal to x upon 80 plus x upon 120. This is in kilo, you can say that kilometer per hour. This is in hour and this is in kilometer. So x upon, on solving, taking x common, so it will become 1 upon, x to x cancel out, 1 upon 80 plus 1 upon 120, that is, it is kilometer per hour. Now taking the LCM, you will get 80 into 120 upon 120 plus 80, 120 plus 80, and you will get it as 48 kilometer per hour. On solving this is 200, obviously you can calculate it as 80 into 120 upon 200, 0 to 0 cancel out, 2 4 ja 80 and 12 4 ja 48, that is 48 kilometer per hour. So this way we had solved two questions. Now in the next video we will discuss about the instantaneous velocity and instantaneous speed. And that's all for today, students. Have a nice day. Thank you all.